Hi guys, and welcome to another lesson. Today we're going to be looking at probability, and we're going to be looking at questions specifically dealing with mutually exclusive events. So the first question that I want to look at in trying to explain what mutually exclusive events means and also how to answer questions on mutually exclusive events, we're going to be looking at the November 2018 paper 1 question that came out there. So in this particular question, it says, given the probability of A is equal to 0.45, probability of B is equal to Y, probability of A or B is equal to 0.74. Determine the values of Y if A and B are mutually exclusive. Now, if two events A and B are mutually exclusive, what it means is that the two events cannot occur at the same time, which means that there's no overlapping of these two circles. So it means that for mutually exclusive events, the probability of A and B must equals to 0. So what we have to do now is use the fact that the probability of A and B is equal to 0. So therefore, we can answer this question using the addition rule, which is the probability of A or B is equals to the probability of A plus the probability of B. Now, because the probability of A and B is equal to 0, we don't have to write the part minus the probability of A and B in the addition rule because it's equal to 0. So therefore, the probability of A or B is given to us as 0.74. Probability of A is 0.45 and the probability of B is equal to Y. So therefore, in solving for Y, you can say Y is equal to 0.74 minus 0.45, and that will equals to 0.74 minus 0.45 equals to 0.29. So therefore we can conclude that Y equals to 0.29. Okay, let's look at another question. Now in this particular question, this appeared in the May-June 2016 paper 1. It says the probability of events A and B occurring are denoted by P of A and P of B respectively. For any two events A and B, it is given that the probability of not B is equal to 0.28. Now this is a very important statement. If the probability of not B is 0.28, then it means that the probability of B is equal to 1 minus the probability of not B, and that is for complementary events. Therefore, the probability of B is equals to 1 minus 0.28, which is now going to equals to 1 minus 0.28, 1 minus 0.28, and that's equal to 0.72. Therefore, the probability of B is 0.72. Now they tell us here that the probability of B is equal to 3 times the probability of A. Now that's how important the first statement was for this particular question. Because now that we know the probability of B, we can write the following. Probability of B is 0.72 is equal to 3 times the probability of A. 3 times the probability of A. Therefore, the probability of A is going to equals to 0.72 over 3. So now we got the probability of A is 0.72 divided by 3, and that's equal to 0.24. 0.24. Okay, so now that we know the probability of A and the probability of B, and in here they tell us that the probability of A or B is 0.96. Are events A and B mutually exclusive? Justify your answer. Now remember that for mutually exclusive events, the probability of A and B is equal to 0. So now they're asking us the question if the events A and B are mutually exclusive. Okay, they're not telling us that they're mutually exclusive, so therefore we have to solve for the probability of A and B, and then we'll decide from there whether they are mutually exclusive or not. Because remember, if the probability of A and B is equal to 0, then they are mutually exclusive. If it's not equal to 0, then they're not mutually exclusive. So once again, we're going to use the addition rule to solve for P of A and B, which is going to be as follows. Probability of A or is going to equals to the probability of A plus the probability of B minus the probability of A and B. So let's solve for the probability of A and B. So the probability of A and B, I'm just bringing this this minus P of A and B to the left hand side. So it will be P of A plus P of B minus P of A or B. So we're just making P of A and B the subject of our equation here. So now if we do our substitution, the probability of A is 0.24. Don't forget to show all of this working here. Alright, that is very, very important. It's a part of the solution. Plus the probability of B 0.72 minus the probability of A or B, there's it here, 0.96. So as you can see, 0.24 plus 0.72 minus 0.96, and quite obvious the answer is, as you can see, 0. Okay, so therefore we've now shown that the probability of A and B, therefore the probability of A and B is equal to 0. So as you can see in this particular question, the probability of A and B is equal to 0. Therefore we can conclude that events A and B are mutually exclusive. Events A and B are mutually exclusive. Okay, and that's how we answer question on mutually exclusive events. Learners, if you haven't subscribed already, make sure you subscribe to JR Maths. Check out all the videos on jrmaths.com, and I'll catch you in the next video.